is Albert Forsen. I'm a research candidate from University of Mauritius and also affiliate to the Ghana Radio Astronomy Observatory. Also the administrator for PRASAC, that is promoting astronomy in Ghana through school visits and astronomy clubs. PRASAC has embarked on several projects or programs since 2018, which include teacher training for science teachers and social studies teachers in our basic schools, also including astronomy outreach activities in schools. These also involve formation of astronomy clubs in the school, where we introduce astronomy and space science topics with a hands-on teaching and learning activities to better understanding of the solar system or the astronomy topics that found in their curriculum. Aside that, we also organize other projects or training for university graduate students, where they also partake in technical hands-on training skills, which is the Astrophy. We also partake in workshop for school teachers that teach school for the blind and the deaf. So these are the major activities or programs that PRASAC engage in over the years. Astrophy project was a program specifically designed for undergraduate and graduate students that are in the field of STEM-related subjects like physics, electrical, electronics, or engineering, and other related subjects or field, which we designed for them to have hands-on technical training in astronomy instrumentation or space science instrumentation, data reduction, and data analysis, Python programming, which was sponsored by the Office of Development of Astronomy for this program. So during this program or training school, students had opportunity to go to the basic Python programming, where they are able to do analyze data or deduce the data, analyze the data. After the Python programming, we take them through how to design a simple telescope. We call it tabletop telescope. So they were able to practice hands on this. We were able to assemble this component and set up a tabletop telescope. After that, they also managed to build or assemble a small telescope to see or understand the movement operation of a major telescope or a main telescope. So these are some of the activities or major activities that took place during this Astrophy school. TTRT is simply called tabletop telescope. The main idea behind this tabletop telescope is to be able to make things simple for a layman or ordinary student to be able to familiarize with moving into that field of expertise. So just put a simple cone or horn, we call it a horn antenna, with a small electronics at the back, and use small SDR which look like USB to your computer. You'll be able to point this horn or telescope towards or raise it up to the sky and be able to collect electromagnetic waves in the radio spectrum and be able to analyze. These electromagnetic waves are coming from the center of the galaxy or the hydrogen line. So this is how it works, and this is just like to a bigger telescope how they work. So we wanted to simplify this down to understanding of a layman. That is why we call it tabletop telescope, and that is function. So I'll be able to take you through this TTRT and show you the parts and their various functions as well. This is the horn, or we can call it antenna or antenna. It's a simple horn, simple antenna, which we use to collect the electromagnetic waves from the galactic plane. So from here, we are able to put on our electronics box. In this box, we have a set of amplifiers and a filter. The function or the purpose of this box or those amplifiers They are able to amplify the weak signal, the electromagnetic signal that we collect from space or from the H1, the galactic plane. We are able to amplify them. Then we'll be able to measure it by this receiver. This is a simple receiver that's used like our USB flash drive. This is what we call SDR. So this SDR is analog to digital converter that should be able to analyze the signal or the data collected by this horn. Now, so this is how it works. We have the horn, and you are able to connect your amplifier box to it. After that, you fix this. Now, also note that these amplifiers are active components, so therefore we need to power it with our 5-volt power supply. So this is a 5-volt power supply. I power this on, so the process starts. This is the output that goes to our receiver, which is the SDR, the output, the signal being amplified. After amplification, it goes through this cable, the SMA cable, to the amplifier. What it has, the receiver, sorry, what it does is that we put this to our the laptop. So the laptop will be able to analyze the data. So we use a simple Python program to be able to collect the data and analyze the data. So that is how it works. And when you look at all these big telescope or how telescope function as well, these are the basic principles in which they function. So we use the reflector, the big reflector, the horn, the amplifier, where we also power those the amplifiers. Then we go to the receiver. Then from the receiver it goes to the computer. Then we'll be able to see the signal and the data that we've collected. So that is how it functions. PRASAC is the main brain behind the Astrophy project, because we have a lot of expertise of students that have gone through this astronomy and astrophysics background or program or training. So our main goal is to be able to transfer this knowledge or these skills that learned over the years to the other younger one. So PRASAC was the main behind, who was able to write all the proposal, look for the funding. So PRASAC is the main organizer of this Astrophy project, and being supported by Ghana Space Science and the other institutions. PRASAC role played here was the one who organized the main Astrophy project, and the objective is to be able to let other students have that basic knowledge or basic understanding that they had, or those who formed PRASAC had earlier. So starting from the tabletop telescope and also to the small telescope, how it works. So they'll be able to have hands-on and practice on that and be able to get understanding on the bigger concept or the bigger 32 meters rule. So PRASAC was the one who organizes this training and bring in the conversion of the small telescope to be able to match that idea. PRASAC team members rally behind this Astrophy project and also contribute their various expertise into the conversion of this small telescope. So this was all satellite dish, and various people with a various background rally behind it, and we were able to help the conversion into radio telescope. And the main function of this small telescope is also able to, one, observe the sun, observe the hydrogen line, which within our galaxy we belong to. So this will also help the understanding of how the bigger telescope works, the engineering aspects, the concepts or challenges that came out with the conversion of the 32-meter telescope will enable the student to be able to solve problems of such in the future. So they were able to go through basic engineering challenges just as the 32-meter telescope. So this is the objectives of the small telescope development. There are so many technological applications that we use every day, and it happens to be that we are the end users, but we don't really understand the concept behind them because we don't ask ourselves how did we come about the internet, the mobile phones, and the GPS that we use, and other satellites that we use. Some of them we use them to watch only television, but we don't really understand how come about some of these technologies. But the mere involving students or organize such a technical program for students, they will be able to understand how some of these technologies came about, the engineering aspect. So our main focus is to introduce the student into this STEM related subject, specifically the engineering or the instrumentation, because we wanted to prepare students or expertise and advance so that they will be able to mount or be able to operate this edifice, this 32-meter telescope in the future. That is why we organize this particular small telescope development. So the beginning or the understanding will begin from their graduate level. So as you can see now, this is a small telescope that has been designed. It has all the key functions of the bigger one, and to also be able to do some form of science or astronomy, to be able to look at the sun, to be able to look at the hydrogen line, especially some bright sources. When it's a bright source, some bright stars, this is able to see that. It will be able to track from azimuth of 360 degrees and elevation of 180 degrees. So as you see now, it's going to about 0 degrees in azimuth and 60 degrees in elevation. We can also change the direction in which we want it to go. It depends on what you want to do, so, and that is possible. So basically, this telescope was being designed here, which I led the team during the Astrophy training. We led the team and we managed to convert old satellite dish into radio telescope. And these are the electronics, the drive system here that will be able to drive the telescope. We manufacture and build everything right here. And this is the horn or the focal that will be able to collect the main dish, collect the electromagnetic waves and be able to direct it to the feed horn. And the feed horn the signal travel through the cable into the lab to our receiver. Basically, that is how it functions. So the function of this and the TTRT that we saw earlier on are not different. The function, they are not different. The only difference is that this is bigger and this can do more analysis or more data comparing to the smaller one. This will be able to track sources. It will follow the stars and the sun. If we change the electronics, this can also work for satellite as well. So basically, this is how it works, and we invite everybody who is interested to learn more to come on board or come here and see more as well. So the main objective of this Astrophy school is to be able to let or help a student to be able to use the Python programming of how to collect data, process the data, and analyze the data. And also by having hands-on training on this astronomical instrument. That's just like a tabletop telescope. So by so doing that, they'll be able to understand how astronomers use their telescope to collect data, process the data, and analyze the data. This can also be translated into several fields, because if you manage to, or you know how to collect data, any data using Python programming, you'll be able to analyze any data and give us the result. So this is what we are looking for. There are so many data around that they can use. They can apply this knowledge to the development of the country. Our very much appreciation goes to OAD for providing funding for this particular project, Astrophy, and keep supporting PRASAC and its activities over the years. Second one also goes to Ghana Space Science Institute and also Ghana Radio Astronomy Observatory. We also extend our profound gratitude to Space Hub Africa, and specifically I'll mention Kweku for your role played and your support that you have put in up, especially towards the conversion of the small telescope. Another thanks goes to Noracel and Sohan. A big thanks to you for your support as you came in and support you gave to some of our students to be able to be part of this project. Apart from that, a big thanks goes to all the PRASAC team members and the students that partake in the project. Thank you.